Welcome to Retro Depot. My name is Doug. Today we are going to be taking a look at the RD10 interface that I designed for the MX-10 computer. The MX-10 is a computer made by Casio, and it's a very low-end MSX computer. Doesn't really have a whole lot going on. It's got a single cartridge port, membrane keyboard. It does have both composite video out as well as RF out, and it's got a cassette interface which you need a special adapter for. You can't just use any adapter for it in order to be able to save the tape. And it's got a expansion port here on the bottom, which was designed for the KB-10 keyboard interface. So, long story short, you can get these computers for anywhere between, let's say, $100 to $200. They do come with MSX Basic 1.0, and there's only a very small amount of memory in these things. I want to say, we're talking about just a few kilobytes. It's not much memory at all. As a matter of fact, you have to have a expander cartridge to be able to play most MSX1 games. You need some type of memory, cartridge to be able to actually play a lot of them. And if you stick one of the memory cartridges in this, then at that point, now you don't have a cartridge to be able to put a game in. So it was kind of a running joke there for a little while that this was a useless computer, because about the only thing you could do is type a basic program into it. You couldn't even, you really couldn't even load a basic program off a tape. Well, they did come out with a KB-10 interface, and the KB-10 interface, it gave the computer the ability to have 2 additional cartridge slots. And it also implemented a printer port, if I'm not mistaken. So, with that, you were at least able to put a RAM cartridge in, and then you would be able to load in 1 or 2, other cartridges in order to be able to, play a game or do whatever you needed to do. It does have keyboard connectors here, so you were able to at least hook up some joysticks to it. But the problem still was that unless you had that KB-10 interface, you really couldn't do anything with it. Well, the problem with the KB-10 interface was because the MSX here didn't fully decode for the signals needed for the cartridge slots for slot 2 and slot 3. You were essentially left with a computer that even if you hooked something up to it, you couldn't really access those. So they had to come up with a brand new MSX engine to put inside of the docking station, if you will. So essentially, in order to buy the docking station, you were buying almost an entire MSX minus the processor and memory, and that made it pretty expensive. So the people that did buy these, most of them didn't opt to buy the docking station. So that translates into a lot of those are not on the market today. So what I've done is I've actually designed a brand new docking station, and of course this is a rough design. It's still kind of a work in progress. It does work though. I'm not going to show that in this video. We'll show that in an upcoming video, because there's a little bit more content here there's a little bit more content than I would feel comfortable putting into one video. So that said, we're going to take a look at this today, the build of it, how I built this thing out. Now there is one thing that I do want to note on here. In the build video, I have placed the buffer chip for the data bus here. In reality, I am not actually using a data buffer at the moment because there's some problems with timing concerning the actual switching between read and writes. So I have decided to instead just use some jumpers that I've soldered into a socket here to be able to stick into a socket on the board. That way I can just bypass that altogether. I am pretty scared about bus contention with this because that's a real issue. So what I've decided to do is probably go the cheap route and use resistors to prevent against bus contention. So, having said that, this is a really neat controller, though. It's got essentially the memory portion and the slot mapping portion of the MSX engine on it, as well as a high capacity DC regulator here. It'll actually give you up to about 3 amps at 5 volts, so that's more than enough to run this computer as well as this and any cartridges that you would stick in here. And it's also combines the audio signals from that interface or from those cartridge slots into a single signal that's sent back to the computer. So everything on this should work. And you know, the only issue that I've had is with some with floppy card adapter. I need to put up a video about that, but I went back and copied a floppy card for the MSX. But if the floppy card is in the second slot, a little bit too much noise. You get a little bit too much noise and it won't really boot right. But if it's in the first slot, that's fine. I think it has to do with the ribbon cable on the floppy. The ribbon cable just picks up some extra transient noise because this thing's out in the open, and it essentially causes a situation where it's got some problems booting from it. But other than that, this works. And like I said, we'll have an upcoming video. I'll show some details on that. If you haven't checked out this project that I've had on my website, I'm going to link it in below. It's got about 6 entries in it so far, and they're fairly lengthy, but it goes through the entire design process. I even posted my schematics on there, that way you can take a look at those. So by the time this video comes out, I hope to have another post on the blog. That way I can kind of show the status of at the moment. But like I said, we are going to be coming out with a video for this as well. So sit back, watch the video, and it's going to be a little bit of a long one. I think it's somewhere in the area of about 40 minutes. But long story short, if you're into this kind of stuff, the design process of you know, retro computer add-ons, this video will probably be pretty interesting to you. And of course, a lot of it's just me talking. I know I probably do that too much, but bear with me. It's just part of my nature. And I do want to give you one little bit of information. I am actually shooting the intro to this about 2 months after I filmed the actual video itself. So this is coming out quite a bit afterwards. And so keep that in mind whenever you're watching this. This video was shot about 2 months ago, and it was actually shot about, I think it was about 2 o'clock in the morning, so I'm pretty tired at that point. So if I don't make a lot of sense, that's probably why. Anyhow, sit back and enjoy the video, and I guess we'll see you in the next one whenever we try this thing out. This is the RD10. It is essentially a clone of the KB-10 docking station for the MX-10 MSX, made by Casio. This is a pretty interesting little board here. The whole idea behind this is that we can expand the capability of that MSX1 machine, because it only has 1 slot compared to most MSX computers that have 2, which means that you're really limited. For example, you can use either a RAM expansion or a floppy adapter, or I guess you could use something along the lines of the SD512, which gives you storage and RAM. But the reality is that you've only got really 1 place to put a cartridge slot, and yeah, we need more than that. We want to be able to see what that little thing can do, so we need to build this up. Now, I've got pretty much all the parts that I need to build this, but for one, and that is the capacitor. For some reason, I am completely out of capacitors, and I thought that I had some that would fit this footprint. Now, I've got some that I can make work, but I'm really not too certain about using them. For an example, I've got a couple little, you know, things that I've soldered together here for testing circuits. This particular one is 220 microfarad, and surely I could use something like this on this board, but I'm just not so certain about having one that's, you know, 220 microfarad. But yeah, we can
we can test it out and see if it'll work. We'll have to you know, make this thing fit by bending the leads in, because it's you know, quite a small little footprint there. I believe that's a 1.8 millimeter lead spacing, or maybe it's 2 millimeter. I'm not certain, but it's pretty small. But yeah, we've got everything we need here to build this, at least with one slot. We don't have enough for two, because we're going to have to use one of these for the edge connector. But we're going to go ahead and get started here. I'm going to go ahead and push some of this stuff out of the way just to kind of move it. And I've got my schematic and board layout up on my computer, and that way I can use it for a reference when soldering all this stuff together. And it should go pretty quick, but it's still going to take some time. So yeah, kind of had to piece together some of the parts for this. For example, I needed a inductor, but a ferrite inductor, but the problem with that was I couldn't find any through Mauser or DigiKey that were the footprint that I needed. So I've got this one here, slightly different. I don't think it's capable of as many amps. This should be good for about, I think it's 2 or 3 amps at you know, 12 volt. This here probably 1.5, I would say. So we're not going to need to put a lot of current on this, but we're going to need to put a little bit. But the first thing that we need to do is take care of the surface mount stuff, which is going to start off with this, what is it, LM2596. So we're going to try to get this up on camera here. As a matter of fact, I'm going to flip this board around so that you can get a better view. I always like to do surface mount stuff first, and the reason for that is that surface mount stuff always seems to be, if you're going to have a problem, it's the piece that's going to give you a problem. And in order to do that, I've actually got a fairly large knife tip. So the way that we're going to do this, as a matter of fact, I'm going to have to flip this around so that I can actually see what I'm doing. This is a rather large part, even for being surface mount. So we're going to put that just like so. As a matter of fact, we're going to go ahead and just tin one of these pads here. And I've got a rather large pair of tweezers here. I don't know if I can get these things to work with me. I actually think we got that straight first time go. Yeah, that actually looks pretty good. So the next thing that we're going to do is we're going to start to solder some of these legs on this. I'm going to have to turn this around so that I can see it myself. But again, I'm using the knife edge, and I am just going to apply pressure to the top and then slide the solder underneath to get it to wick. And that should provide just about everything that we need on these legs. We can always go back and clean this up a little bit after the fact. As a matter of fact, we're going to need to wick that just a little bit because we've got a solder bridge. Just a little bit more. There we go. Alright, that looks good. Now I'm going to go ahead and flip this around again because we are going to want to solder the pad on here. I need to get to a position where I can do this. Now, really this is kind of a harder part right here. We need to get this thing heated up enough to be able to wick up underneath it, and that can take a little while. I guess in theory we could actually lift this thing up just a hair, but yeah, there we go. Now we're starting to wick up underneath it. Mostly, this isn't super important. It's mostly for thermals. This doesn't really connect to anything on the board, but we do want it soldered down because we want it to wick that temperature away from the part itself. So that is the difficult part. So we can zoom out just a little bit now. And the next thing that we need to do is actually let the iron cool down, because we need to switch out to a different tip. So I'm going to go ahead and stop the video, and we are going to let this thing cool down. I'm going to change out the tips on it, and we will start up the process of building this board. So whenever you blink, I'll be right back. Okay, we're back. I've got my tip changed out. Need to clean it up just a little bit. There we go. That looks a little bit better. So the next thing that we need to do is solder in the resistors. Now I have designed this so that it is very, very simple. It's got a whole bunch of pull-up resistors over here, and these are the resistors used to combine the audio input. Now on the MX-10 it uses 220 ohm. But I've decided to use 320 ohm because that is what I have, which is fine because it's going to take this and it's going to mix it on board, and yeah, it'll work out pretty well. But we do need to go ahead and get these things soldered in. So in order to do that, I'm just going to take these things and populate them real fast. Now, really these things aren't too critical. On the final version of this, I'm probably going to end up putting an amplifier in here anyhow, and then I'll still have to have another resistor to mix it in with the motherboard on the computer itself. But you know, this is going to work for now. Like I said, we really only care to test for sound once we have something to mix sound with, and I don't really have a cartridge that has a sound processor on it. I guess I could probably wire one up with, for example, the SAA 1099, like on the used in the PC, or I can even use a whatever the Texas Instruments 3-voice sound chip was, and a couple others that I have on hand. I could mix any of those, but the reality is that I don't really feel like building a card just for that, especially whenever something that's not supported by any software. So I need to sit down and build something. I just haven't gotten around to it, and so therefore I'm not really too worried about the audio mixing on this particular board. This is mostly just to be able to expand the slots, and considering this is the first test run of this board, I decided that it might as well have it in case it does work, but if it doesn't, it's not really going to hurt my feelings any. As a matter of fact, I may not even solder in that capacitor. As I mentioned before, we don't really need it to test this as far as whether or not the slots are going to work, because I'm going to be frank with you, I don't have any idea. I don't have any idea whether or not this will work or not. Now, I have a suspicion that it will, but I am not 100% on that. And honest truth is, if this doesn't work, I'm not going to be out a ton of money with what I've got in it. So we're going to go ahead and just get these things soldered up. I'm going to come in here from this angle. Get some slack in my solder. There we go. just a little piece of advice whenever it comes to soldering stuff like this. It's always nicer to have a little bit larger tip than what you think you will need, because it does help to add a little extra heat. You don't want a ton, but you definitely want enough that you're not sitting there trying to solder each pin forever. It's kind of the trick with soldering. And you know, like I said, I'm just kind of a hobby guy here. I don't really have a ton of training for anything in particular, but one of the things that I've learned over the years is that I'd rather have just a little bit more heat than what I need than not have enough. I guess that's just like anything else in life, but yeah. Make sure. Oh, we got one that kind of stood up on us just a little bit. Actually, two that stood up on us just a little bit. So we're going to fix that. Okay. And the other one is going to be right there. Alright. Then on this back side, there we go. So I'm not sure if you saw that or not, but if you didn't, it's okay. Just making sure those things are seated flush. And we're going to go ahead and get these last three here. As it sits right now, I think we have a total of 11 resistors on this board, so really not that many. Most everything is, you know, digital, HCT logic, you know, CMOS. But it's got to be at least HCT, because the MSX standard calls for TTL. So we need to make sure that we can talk to those logic levels. And if you look at this computer, the Jelly Bean logic on the inside is in fact TTL. It's all, you know, 74LS stuff. However, interestingly, I believe the processor is a CMOS processor. So, kind of interesting how they mix the two of those. Alright, so I think that's all of the resistors, so we'll need to go ahead and snip these. Now, just a little bit of information. I guess that the actual proper way to solder anything like this is to actually put it in, clip the leads, and then solder it. But I've never actually done that. I guess they say it stresses the joint whenever you do it like this, but I'm going to be frank with you, as long as I've used a good solder and a good board and a component with clean leads, I've never had a problem with having a joint stay together. Now, obviously, I haven't had anything that I've really tested for longevity, like, you know, 10, 20 years, but I have a hard time believing that any of these joints are just going to break away. I think that was a bigger issue with older solder that was, you know, 95% lead or whatever it was back then, with just a very minimal amount of tin in it just to kind of help it flow a little bit. But yeah, that looks good. Not seeing any issues. Got one resistor that actually stood up just a little bit. I can take care of that real quick though. So there we go with that one. And that one. And yeah, now it sits flush. Okay. Now the next thing I need to do is start figuring out where some of these components go. I'm going to have to bring up my cheat sheet. So the next thing that we want to do is figure out what's the next lowest sitting component. That's probably going to be this 1N5822 diode. This is used in the voltage regulation section. So we're just going to go ahead and bend the leads on this down. These are some pretty thick leads from what you can tell. But they actually sit pretty flush with a lot of the other components. It's a pretty big diode. This is part of the switching regulator circuit here. And this thing takes a little bit of heat to get it soldered. It's not the worst, but especially on this ground plane. I had actually never heard of this part before until I built one of the Harlequin computers, one of the clones of the ZX Spectrum. And actually, I may have a use for that. I'm going to keep these. Anyways, whenever I built that computer, it used one of these circuits here, and it's actually pretty straightforward. You have a DC jack. You've got a bridge rectifier. You've got a capacitor, a switching regulator, a toroid, a diode, and then a output filter capacitor. So it's actually pretty nice. I really like how well that circuit works. Looks like I forgot to put a couple of these out here. Also need to get a bridge rectifier, which I actually have a bunch of those. I've designed it to use these little 2W10s. They're supposed to be good for 2 amps. As a matter of fact, that's the next circuit that I can put on here. Have to spread out the leads on this just a little bit though. Ooh, okay, so that's going to be positive, negative. There we go. Oh, just like that. Like I said, these things, they sit pretty flush with everything. That's the great thing about the components that I chose here. All these things are just really good components and they work together really well. A little bit of a ground plane right there. Takes a little bit more heat on those, especially when you get a thick lead. Okay, snip those off. Again, I'm going to save those just in case I have any need for like a thicker post. Don't really know what I'd use them for at the moment, but never can tell. They sure do beat trying to use resistor leads whenever you need something a little bit thicker. Okay, next up, I think that we're probably safe to start soldering in some of these ICs. Gonna need to figure out exactly what I could probably work along this way. So let's see, first up is U3. So that's going to be a 74 LS07. Not that one. Not that one. There we go. So take that. I see bend the legs down just a little bit. We're not going to use sockets on this, but on the PLD, we are going to use sockets on the PLD. So the way I'm going to do this is just like before. I'm going to take one of these legs and kind of bend it out just a hair. And on the opposite side at the other end, I'm going to do the same thing. And that's going to give it just enough of a bite there to hold itself in place. Now, next up will be the 74 LS243, which is this one right here. So we can go ahead and get this thing put in there as well. That way we can solder as many of these at one time as possible. That'll help to speed up the process of building this. Another thing of note, whenever you're building these things, if possible, try to make all your ICs face the same direction. That'll really help you whenever it comes to trying to diagnose this kind of stuff. It's just good advice. I think it's something that's not stressed enough. Now, sometimes it makes sense to flip an IC around. For example, if the pins are going to be connected to pins on the other side of an IC, that kind of makes sense. But the reality is that if you can keep them all the same direction, it just makes it easier whenever you're trying to figure out the pin out of these things, especially if you're working from the bottom side of the board where you probably don't have any silk screen. So, like I said, that's just my advice. And I guess in theory you could actually put silk screening on the bottom of the board as well. I don't see anything that would prevent you from doing that, but it's definitely probably to your benefit to go about it the right way. So we're going to have a 74 HCT 541, 541, and then a 245. So we have to make sure we get the order of these things correct. These 74 HCT 541s they are octal buffers, whereas the 245 is a octal transceiver. In other words, the buffers go one direction, the transceiver can go both directions. So we need the bidirectional for the data bus. That's the one piece that we just absolutely want to make sure is bidirectional. Just about everything else you can make it work unidirectional if possible, with having extra gates and things like that. But yeah, you definitely want to have those there. Alright, next up is going to be another 541. So this is actually pretty convenient. It was almost like the guy that laid this out knew how to lay out a printed circuit board. I know, I'm talking myself up. But having said that, I've been doing this for about 10 years now altogether, playing with electronics in one way or another. And I will say, without any shadow of a doubt, that I am much better today than I was 10 years ago. Okay, this is at 74 245. So we're going to go ahead and get that in there as well. Like I mentioned, we're just seating all this stuff so that we can go through here real quick and solder all the leads on it. If possible, I may even speed up this part of the video. Although the video editor that I've been using, which is open source, or OpenShot rather, it doesn't really play well with trying to do weird stuff like that. Okay, this is the 74 HCT 573, and this is a transparent octal latch. Whenever you're getting ready to latch the bits on this, apparently the bits propagate on the outputs before it actually latches. So thus the transparent latch portion of this. I haven't ever had to really use any of those, but if you have a need for it, then you have a need for it. And in this particular situation, I'd rather have the data present as soon as possible than without. This here is going to be a 74 HCT 153, and that is going to go right here. So we'll go ahead and get that seated. Looks like I bent the lead on that just a little bit too much. There we go. you know, the reality is a lot of people would prefer to socket stuff like this, but on something like this, where it's kind of just all jelly bean stuff, there's nothing that's really super expensive on this board. Probably the most expensive thing would be the one thing that you would definitely want to have socketed, that is the PLD. Aside from that, the next most expensive thing is probably the voltage regulator and then the connectors. So the connectors are like $5 a piece, and the voltage regulator, I think it's about $9 through DigiKey. Maybe it's 10. So yeah, double check that just to make sure. Yep, that's the 7400. So we'll go ahead and get that seated there. Okay, and the last thing that we have is well, I'll say the last thing, we still got to put the capacitors on there, but we need to put, actually we're going to wait to put that socket in there. We want to solder all these first because these are going to sit a little bit lower than that socket. So, yeah, let's just go ahead and get after this. So we're going to make sure we got a good clean tip. And this should go pretty quick because I've got a larger tip here with my heat set to about 380°C. So, shouldn't really take too long to solder all these, although it does take a little bit of time. You know, I will say this, as much of a pain in the butt as it is sometimes to, build PCBs up, sometimes I really just enjoy doing it. And I think I mentioned that before. It's kind of calming to me to an extent because it allows me just to zone out and take care of whatever it is that I'm taking care of. And, whenever it comes to building these circuits, probably the one thing I hate the most is breadboarding, followed up by perf boarding, followed up by strip boarding. Probably wire wrap would be, if I was going to have to prototype, I'd love to do wire wrap, although I've never actually done wire wrap because sockets seem to be either nearly impossible to get or they're just so expensive that it really doesn't make sense to do it that way whenever you can order circuit boards for $2 from China. So a lot of times whenever I get ready to prototype something, just easier to order from China. It's on a circuit board. At that point, you know whether it works or not. You've already got your design laid out for whenever you do finish it up. If you have to go back and make a couple changes, you've already got most of your design laid out. And if you do have to go back and change a whole lot, you're still on a circuit board. And unlike a breadboard or anything like that, you don't have to worry about as much noise. You don't have to worry about your wires breaking over time. It's just like any other circuit board. You just have to take care of it as though it were a circuit board. And I really enjoyed that part of the phenomenon that we have going right now with these cheap circuit boards from China. I honestly don't understand how some of these companies can even make a profit with what they're selling them for. But, that's the way it goes. And the honest truth is I would actually prefer to buy from somebody here in the United States, but man, it's just kind of a no-brainer. You look at some of these places that you want to order circuit boards from, here in the States, and shit, it might cost you $150 for just a couple circuit boards versus $2 from China. Like, it's just a no-brainer. You cannot compete with that. I don't know how a lot of those places haven't gone out of business. But, that's the way they end up getting technology that allows them to compete in markets where they wouldn't normally be able to, and we are the ones that benefit from it. So I'm thankful for that. We are about a third of the way done with the ICs, I think. Almost, anyhow. my goal is to get this done faster than the last one. The last board we built was the floppy card for the MSX, and I think that one took me about 45 minutes to build, and I don't think we're going to make it. Judging from the time on the clock here, I've already done 24 minutes, and that was after I changed tips, and I think I probably had 5 minutes in before that, so I'm guessing I'm at 30 minutes right now. I think this is probably going to be a little bit longer. So, oh well. Takes time, I suppose. See how much smoke is rolling off this? This is what I was telling you the other day about having a fume extractor. I probably ought to get one, but you know, like I said before, it's probably the least of my worries. I'm a smoker, so I've got that going for me. You know, really probably should quit, but yeah, like I mentioned before, you also have to have a vice. And if drinking coffee and smoking cigarettes is the worst thing that I do socially, I think that I'm probably doing okay. But, you know, with this stuff, it's pretty nasty stuff, man. I'm just glad I don't do it every day, but I probably should get a fume extractor. Maybe I can 3D print one. I've seen a couple guys do that. I've got a couple 120 millimeter fans somewhere. Should be able to print one up, and I guess I can get some of that carbon filtering material. And you know, I've got to wonder whether or not that stuff is actually, you know, even doing anything. Obviously, it's pulling the fumes out of your face, but is it really filtering anything? Like, is it making any difference, or is it just like dispersing it into the air that you're already breathing anyhow? Like, I'm pretty leery about whether or not a lot of stuff like that works. You know, I went through NBC training while I was in the military, and if you don't know what NBC is, it's nuclear, biological, and chemical. And one of the things that I learned very early on is that, like, pretty much all those things that you believe are helping you, like gas masks and things like that, they're just there to give you comfort. If you actually need those things, you're probably already dead. You know, and it's the same thing about whenever you detect those things. By the time you detect them, you're already dead. You know, you got to be wearing that stuff long before there's a need to wear it. Otherwise, you're not going to have time to put it on. Of course, that's just my experience, and of course, you know, people are probably going to chime in and tell me I'm wrong. But dude, like, I actually went for some schooling on this stuff, and yeah, like, pretty much you're already dead. Same thing with your face mask that you're wearing right now for the pandemic. It doesn't do what you think it does. Certainly, it probably does offer a certain level of protection, but not to the extent that you believe it protects you. Like, it's just not the way it works. Now, it does kind of help you keep from spreading it to a certain degree, but even that's fairly limited. But, you know, face masks aren't new for, you know, people that are sick. They've been doing that in Asia for a couple decades now. I remember back in the 90s seeing videos of people in, you know, Hong Kong walking down the street with face masks on. And I asked a long time ago what that was about, and they said, you know, hey, whenever you're sick, it's customary just to put it on. They understand you got to get to and from where you're going, but it's just kind of the social norm. They've been pushing that kind of stuff for a long time over there because, you know, it does help you keep from spreading it a little bit, but you're not protected, if that makes any sense. So, of course, I live in Oklahoma, and if you don't know anything about Oklahoma, nobody here believes that the pandemic is real. I say that jokingly because, you know, I believe that the virus is real, and I believe that a lot of good people have died because of it. But most people here believe it's a hoax, from what I can tell. Well, I say that. You got about 50-50. Of course, it's also really weird because these are the same people, you know, that 2-3 years ago would have been telling everybody, you know, that wasn't vaccinating their kids that they were anti-vaxxers, that, you know, what are you thinking, you know. And now they are the ones on the opposite end of the spectrum talking about no, they're not going to take a vaccine. I'm just going to go on the record. I got the vaccine. I took a look at the research, and it may not be the best protection out there, but it is better than nothing. And at the end of the day, I don't think it's going to harm anything. So, you know, I could be wrong. I might wake up here in a couple months and have grown a, you know, fourth limb, or maybe a, you know, extra head on my shoulder or something along those lines, but I just don't think that there's anything dangerous about that vaccine. And I specifically got the Moderna, but you know, it's one of those things. The way I look at it is you can't live your life in fear. Eventually you're going to have to go out. There's always going to be some different variant of this, whether it be the new Delta variant or the super special, you know, K variant or something along those lines. There's always going to be some other version of this virus out there. It's here to stay with us, and you can either go on living your life and, you know, just be happy, or you can, you know, lock yourself inside and just, you know, say that you're gonna, you know, wait it out and you're doing the right thing and that, you know, you're saving lives. Whatever, man. Whatever floats your boat. I'm not gonna judge you, but for me, I'm gonna live my life. You know, I'm getting close to 40, and I'm vaccinated. The only way that you're going to build up any real, you know, resistance to this virus is to get out there and, you know, actually be exposed to it. Certainly, some people, you know, have medical problems and they need to keep themselves, you know, away from it. That's fine. Go out and do what you need to do. The rest of us got lives to live. I'm not going to judge you. You probably shouldn't judge me. Of course, that's probably an unpopular opinion these days, but, you know, I'm also not a guy that really gives too many cares about opinion. You've got yours, I've got mine, and just like my mama used to tell me, they're just like buttholes. Everybody's got one and they all stink. So, oh. Alright, let's see about getting this one in here. This one's, yeah. Always hate messing with these. They don't really like to stay put. Bend those out just a hair. Yep, there we go. Alright. We are just about done with this. Getting pretty close. I might be able to beat that time. I don't think I'm going to. Currently at 32 minutes. It's going to be close. But you know, this is a lot bigger board. Of course, whenever I shot that other video, I also wasn't working at my peak performance. My sinuses were killing me. I'd been talking on the phone all day. I was trying to keep my voice together for the camera, just so that you're not sitting here bored as shit. You know, at least you can hear me talk. I've been told that I have a radio voice and that people like listening to me. It's probably because they've never heard somebody with an accent as poor as mine. No, but for real, I've actually been told I should do talk radio. Ever since I was a teenager, I was told that. First person to tell me that was my cousin's mother. She told me that I should do talk radio. I was like, what's talk radio? She's like, oh, it's where they get on there and talk. I was like, oh, okay. So, you mean like the radio? I didn't know what she was talking about at the time. I was like, what are you talking about? Like, guy on the radio is always talking. You know, is always telling us what song it is. You know, new hit, whatever. I didn't realize that she was talking about, like, you know, sports radio or conspiracy TV radio, talking about UFOs and Bigfoot and werewolves and stuff like that, whatever it may be. I just thought she was talking about radio. So, But you know, the funny thing is back whenever I was a kid, I was really naive. Anything you told me, I took it at face value. And whenever I say face value, I mean like the literal translation of the words that came out of your mouth. Um, if it wasn't something that was just absolutely obvious, I didn't know what you're talking about. I really didn't. So if you told me talk radio, I thought you were just talking about like the DJ talking on the radio. So just one of those interesting little facts about my life. Took me a long time to figure out that, holy shit, there's something called jokes out there. And then I got really good at them. The only problem is I don't know when to stop telling them. Kind of been called a joker over my life, and well, that's okay by me, but some people don't appreciate it. I don't really care though. I'm gonna do what I want to do. But damn, we just might beat that time. It's gonna be close. Well, maybe 34 minutes, almost 35 minutes. We got about 5 minutes to finish this thing up. I don't think I'm going to make it though. I still got at least 100 pins to solder on those part edge connectors. Okay. Those are done. Last thing would be this ferrite, or this toroid. I think that's the actual proper name for a inductor that's made with a ferrite core is a toroid. Like I said, I wasn't really trained in this stuff. I know what it does, just from having taught myself, but okay, so that is the board. Now we got to put this on, and this is going to actually be a little bit of a chore. What we are going to need to do is try to, because the width of the pins is thicker than the PCB, and we need to be able to make this so that it doesn't slide around. So I'm actually going to have to take a small little vise and try to bend these pins in so that we can make this thing work. And what I'm going to do is, it's actually got a little bit of a ridge here. I'm not sure if it's going to be enough to make this thing seat. Yeah, it looks like it will a little bit. I don't think it's going to be enough though. Maybe a little bit. It didn't do a whole lot. So we're going to have to open this thing back up, and we're going to have to stick it down in there just a little bit further. Ooh. Alright, that probably did a little bit better job. I like this vise design. I found it on Thingiverse, but I actually made a comment. It's really a neat design, but man, you have to turn this thing so many times just to get it to, open up wide enough to do anything with it. I actually made a comment about it, and there was a guy that eventually went back and redesigned it for, people that were complaining about it. It wasn't even the guy that did it. It was a what do you call that? Where they actually go back and they redesign somebody else's stuff. Nah, I can't remember. But anyhow, yeah, he went and did that and actually commented on the comment that I made. And I've been meaning to go in there and actually print it off and see how well it works, but it is one of those things that I just haven't had the time or desire to do it. Been working on other stuff. This is kind of looking horribly unstraight, but that's okay. We don't need it to be perfect, we just need it to work. Alright, so just so that you can see what I did there. Now we're going to stick this stuff on here. Looks like this is just wide enough. Not even by much. I'm talking about just wide enough to get in there. So we'll have to solder one of these, and then we'll have to go back and adjust where it's sitting on the board. So we're just tacking it down. I'm going back to the other side. I'm looking at it to try to make sure it stays straight. And that looks pretty good. Yeah, that looks pretty good. So I'm going to come back on this end, on this side rather, and I'm going to tack down one of these corners just to be able to get it to stay put. So that looks good. Do one more on this end. And there we go. I think that's going to stay put, and we should be able to come through here and solder up all the rest of these. This actually won't take too long. We don't need to make sure this thing is perfect, we just need to make sure it's connected. Because this is mostly just a rough draft of what will hopefully be a final product. Not that there's going to actually be a product here, because this is mostly just for me. You know, if I've got a couple boards and somebody contacts me, I'll probably hook you up. You know, if you want to cover the cost of just the board, what it costs me to get it, and ship it to you, then I'll probably do that. There's probably not a ton of people out there that are looking for docking stations for an MX-10. This was mostly just an exercise in can I do it, which we're going to see. We're going to see if I can do it. Like I said, I don't even know if this is going to work. Now, from what I know about the MX-10, and you know, having probed around inside and look at schematics that other people have done, yeah, it's probably going to work, but you don't know until you try it. I may have to make a couple bodges or something along those lines, but for the most part, everything lines up so far anyhow. Okay, that looks good. Let's flip this around. Start doing some of these other ones over here. Funny thing is, whenever it comes to this card edge that's on this board, I actually didn't even use a card edge footprint. I just laid the board out how I wanted to. I laid some really thick traces down, you know, at the proper pitch, and then I just uncovered them with some polygons and eagle in order to expose them. And then because they were traces, I just named those traces the same names as the connections that they went to. And yeah, that's how I did my footprint for this particular board. And one of the reasons for that was because there's going to be certain things that were connected together, and it just made sense to try to do it a little bit closer to the board's edge. So, but yeah, I like how it came out here. Now, eventually, I'm probably going to go back and whenever I test this and make sure it's working and make whatever changes I'm going to make to it, I think I'm probably going to go back and have this thing finished in a gold. You know, have a gold-plated pads and connectors on it. I forget what they call it. It's like ENIG. It stands for electro nickel immersion or something along those lines. But it's like a nickel gold alloy, I think. I don't know all the technical stuff behind it, but that's essentially what it is, I believe. Some of these are requiring just a little bit more solder than what I thought they would, but it's because they're still kind of stuck up a little bit. Could have pushed them down and made it work a little bit easier, but that would have taken more time. Okay, so that actually looks good. A couple of those look like they can be pushed down just a little bit. So I'm going to go ahead and do that now. I think that may have been the only one that needed it. Double check this side. All of those look good. Every single one of them. Okay. So for the last component here, make sure that's seated nice and well. And we are just about done. 46 minutes. Just clicked over too. Well, in comparison to the last video that I did this with, it actually has gone pretty quick. So, I guess I can't complain about that. You know, I don't really anticipate there's going to be a lot of people interested in this particular video. The honest truth is I'm mostly doing this for my own record, which doesn't make any sense considering I've been sitting here talking the entire time. But if you follow my blog on my website, I have actually been working on this project for a little while. And mostly just a record in case anybody else comes behind me and decides to try to do something similar, that they've got a little bit of an idea as far as what I did, and they can use that to their advantage. You know, that's the great thing about pretty much everything on the internet these days whenever it concerns electronics. We're able to look at what other people have done and build upon that. You know, it's sort of like whenever it comes to building, you know, like Z80 computers, like DIY Z80 computers. You know, there for about 10 years, I think pretty much anybody that built one starting off with, the first thing they built was probably Grant Searle's, simple Z80 with MS Basic 4.7. And that's where I got a lot of the inspiration for my G80 build, was actually from his. The only difference between mine and his is obviously, besides me using different parts, I wanted mine to be expandable, and I wanted it to have I/O on board because I was used to dealing with like Arduinos and things like that. And essentially what I was envisioning that to be was like the Arduino of the retro homebrew computer genre. You know, it would have, you know, expandability, i.e. the entire Z80 bus would be broke out. It would have, you know, 2 serial ports. That way you could connect to, you know, let's say a computer, and then connect to a, you know, another, you know, device, whether it be, you know, some type of storage media or whatnot. And then it would also have onboard I/O, so that while you were programming, you could, you know, actually test to see if your stuff works, like blinking LED and things like that. You know, it sounds stupid, but that's kind of what I was going for. And, you know, turns out that there was a lot of people out there that, you know, thought it was a decent computer, and I've, you know, mailed a lot of those boards over the years. You know, one of the guys I mailed it to down in, I think he's down in Texas if I'm not mistaken. Anyways, he's an old school engineer, but whenever he did a video on the computer, it was actually kind of interesting because he said, you know, this guy, he sends a PCB and the programmed PLD for, you know, the price that I sold it for, which, you know, it's pretty much always been $14, but I think at the time I'd sold it, I had them on sale on the website to kind of get rid of some of the older versions of the board. Anyways, he bought 1 or 2 of them, and his comment on there was that he doesn't see how I could provide those boards for, you know, with the PLD for $14. And the answer to that question is actually pretty straightforward, because I would order like 50 boards at a time, and a lot of times I'd get them from China, whether it be, you know, Ella Crow back in the day, or, you know, today, you know, one of the other companies, for example, you know, Seed, or you know, JLC PCB, or whoever it may be. But I would order like 50 boards at a time, and then I would order like 50 you know, PLDs from, you know, a connection, you know, over in the Asian market, because that's essentially the only place that you can get them. And I just bought enough of them so that, you know, with the overhead that I had into it, I could provide those boards, because I didn't have a whole lot of cost into it. Now, I had time, because I had to wait forever in order to get that done, but I didn't have a lot of cost, and that was the key, the cost. So that said, we're going to need to test this now. So I'm going to get a charger here. Actually, we're going to have to get up underneath the camera. And I've got a multimeter. This is just a cheap one that I use. Nice to have on the bench. So we're going to turn this on to DC. We've got our voltage here, so we're going to go ahead and plug that in. And now we should be getting 5 volts. So go ahead and test this right here. And we are getting 5.02 volts. So that is working. Nothing seems to be getting hot. That's always good. Oh, we are not done. I just realized this, but we actually have the filter capacitors that we need to stick in here. So, hey, but at least we know it works. It's probably flipping all over the place and doing all kinds of random garbage right now, but yeah, it's working. So, all right. Always keep a ton of these things on hand, because you never know when you're going to need, you know, 12 or 13 of these little 100 nanofarad capacitors. You got to have one for each IC. That is the standard practice. Each individual integrated circuit needs to have one of these things right next to it. And then if you're dealing with, for example, microcontrollers or something like that, you may actually want to have, you know, several of these things. Especially you get into like FPGAs and, you know, larger microprocessors, for example, you know, x86 architecture and things like that. You may need like 10 or 12, you know. I mean, that may be the recommended amount that you have. So always keep a ton of these things on hand. You know, I used to keep those little disc capacitors, like, you know, 0.1 mic disc capacitors, but you know, those things just always wondered how well those things are built. These little monolithic ones like this, they just seem like they are built better. Now, they may provide no better protection against, you know, current. They may be just as durable. You know, voltage, you know, oscillations may, you know, happen more often with these than the other ones, but these things just give me a little bit more comfort, if that makes any sense. So we've got those things in there. Oop, I need to bend out the legs on this one. So we are just going to run through here and solder this stuff real quick. Need to get rid of that charger though. This won't take us too long. You guys can see, can't you? Looks like you can. Although the camera may be backed out a little bit too far, or maybe farther than you would like, but it appears you can at least see. Let's scoot this thing back over. I'm not going to torture you guys with cleaning this. I'm going to clean this once I get done building it here in just a second. And then as far as the video on its operation, that's going to be another video, and the reason for that being is because I don't feel like booting up the software in order to program the PLD. I need to get in there and start cooking dinner because it's actually close to 7:30 at this point, I think. Although we tend to eat a little bit late in this house. Yeah, I typically don't get started on dinner until, you know, 7:30. Sometimes as late as 8 o'clock. But I'm also a little bit of a night owl. I have a hard time going to sleep before, you know, 2, 3, 4 o'clock in the morning. And at the same time, I've worked days for like the last 10 years. It's just I worked so many nights for so long that I kind of got on that schedule, and it's hard for me to break it at this point. Because I can honestly say I think I have worked nights since, like, man, I want to say it was like 2003 or 2004. Somewhere in there, and that was up until 2012. Whenever I got back in 2012, I was looking for jobs and went back to bartending for a little while, and was up late at night. But as soon as I got an opportunity, I took the first law firm job that I could find, and that's where I'm still at today. So I've been working, you know, 8:30 to 5 for the last 10 years or so. I guess going on 10 years. Alright guys, that is it. So that is the board. Like I said, we still gotta test this thing, and in order to do that, we are going to need to program our PLD and get it stuck in here. But yeah, I think that's gonna work. So here's what we need to check. We need to see if that thing fits, because that would be a real shame for us to have done all that work on this computer only to find out that this thing does not fit. So let me back out just a little bit, as far as I can. Okay, so moment of truth. Ah, there we go. No hands, Ma. So, yep, got plenty of room for it. And of course, it'll sit like so. And the cartridges they'll be back a little bit from the computer. So they will sit right here like so. I'm not going to press that down because it doesn't have anything holding it up. But if you look at the orientation of it, it's yeah, even my footprint was good for that. So you take a look at where it would be. Yeah, so looking good, looking good. Now the question is can this thing power that? And I can't really test that at the moment because I need to get that PLD in there first. Otherwise, you're going to start getting random stuff happening with the bus transceiver, and yeah, we don't want that. But I'll probably play with it tonight, and once I get a video, or once I get it working, I'll post a video and show it in operation. Or I will be back with a video that basically says, I'm a retarded, and yeah, this doesn't work, and it was a horrible idea, and you guys wasted an hour of your time, an hour and probably 5 minutes of your time watching me do this. So, if nothing else, you got to hear me talk. You probably will never get that hour of your life back. I'm just throwing that out there. Alright guys, well thanks for watching the video. If you did manage to stick all the way through it, if you didn't manage to stick all the way through it, well, you're not here, so I don't have anything to apologize for. But for real, everybody, thanks for at least stopping in, watching it for the 5 minutes or so. Check out the website. Like I said, there is a total of 6 write-ups currently on this. I'll have to do another video or another write-up since I've built this, and we'll figure out what we're gonna do from there after we get the testing done. One of the things I really want to do with this actually is to I was thinking about it the other day. If I decided to go through here and do like a slot expansion, I could do like slot 3, sub slot 3, and I could actually put on that floppy drive, interface on this board. Now it would stick out further, but as you can see, I actually have room for it over here. And at that point, you've just got the header with a breakout cable, and my next version of this board, I already have a connector here that could be used for hooking up the floppy drive, because you're going to have enough current with the 12 volt and you're going to have enough current with the 5 volt, I think, in order to be able to run the floppy drive and the machine itself. So that's something I'm thinking about. I don't know how well it's going to work. I also thought about putting maybe a sound generator on here. We talked about that earlier. But yeah, if this works, this is going to be a fun little toy, I think. Lots of things to think about here. But again, like I said, I won't take up any more of your time. Enjoyed having you guys. If you liked the video, give it a thumbs up. If you didn't like it, thumbs down, obviously. Believe it or not, even a thumbs down helps my metrics. It tells me what you like and what you don't, so you're not going to hurt my feelings by giving it a thumb down. That said, though, again, thanks for coming out, taking the time to spend with me, and we will see you next week or next video, whenever it is. All right? So, have a good day.